series, because if you know, this chapter name is sequence and series. So it has two parts. We have already finished with the sequence part. Just one more question we will do just to connect, and then we will start the infinite series. Yeah. So the question is, does the sequence, this is the general term of the sequence, n plus 1 by n minus 1 raised to power n. We have to answer, is this sequence convergent or not? So how we are going to do that? So we'll be just applying the limit method. So we will be evaluating limit n tending to infinity an. So that will be limit n tending to infinity n plus 1 by n minus 1 raised to power n. So how we are going to find this limit? So usually we know there are many methods of finding the limits depending upon in which technique you are expert in and on which question which technique is applicable. But there is a general technique that whenever n is coming in the power, so the way to evaluate is we take the logarithm of that, because it is not becoming any of the standard limit. If it would have been any of the standard limit, then we would be just using that formula, but it's not like that. So we will be taking log on both the sides. So let me write again. This is n plus 1 by n minus 1 raised to power n. If you take log on both the sides, so this will be n log n plus 1 by n minus 1. And after taking the log, you take limit n tending to infinity. So now when you will be taking limit n tending to infinity, so this is becoming this. So now you have to solve this one. So if I am trying to solve this one, so this is limit n tending to infinity log n plus 1 by n minus 1 by 1 by n. I can write it in this form because this n is coming in the multiplication. I can write divided by 1 by n. This way I'm getting it in the form 0 by 0, because you can see that when I'll be putting n goes to infinity, so this part is going to be 1 separately, because n plus 1 by n minus 1 will be 1 plus 1 by n by 1 minus 1 by n. So this part will be going to 1. So log 1 will go to 0, and 1 by n, the denominator will also go to 0. So if it is 0 by 0 form, this limit is 0 by 0 form. So we are just going to use L'Hopital rule there to solve this limit. So further applying L'Hopital rule, so you will be differentiating above and you will be differentiating below. So you can see this will be your expression 1 by n square. And if you will be solving this one now, the answer will be 2. So we were solving log an and this side limit n tending to infinity. So you got this one. So now finally it's easy to see that this is e raised to power 2, right? So since an converges to a finite and unique limit, according to our method of limit, if the limit turns out to be finite and unique, then we say the sequence is convergent, because that's what the main question was asked. Yeah, that was the main question which was asked. So we have answered that this sequence is convergent by the limit method. So when you will be looking at these kind of questions, see, whenever we are doing one question, do not just focus on that question. Try to get a general technique which can be applicable to other questions also, right? So that's what I told you कि जब भी power में you see n or 1 by n या n का कोई भी function coming in the power, so the technique to solve that is take logarithm. When you take log and then you apply limit n tending to infinity, so then you will be definitely solving it in a better way, because without taking log, it will be of the form, it will be of the indeterminate form. As you can see, this is 0 raised to power infinity form if you do not take the log, which is the indeterminate form. Yeah, so this question was, I'm just repeating it as most of you are saying, this sequence converges or not. So we are taking this limit. We want to evaluate this limit. So if you just look at this limit and try to evaluate it directly, so you can see what form it is. So this can be written as 1 plus 1 by n over 1 minus 1 by n raised to power n, right? So this is 1, this is 1, because it will go to 1. So this will be approaching something 1 raised to power infinity. So, but we cannot write it exactly equals to 1 because that's not exactly it is. So we have to have change the indeterminate form. So to change the indeterminate form, जब भी power में infinity या zero आ रहे हैं, that means वो n की वजह से आ रहे हैं. So remember it as a general rule. Whenever n or 1 by n or any function of n is coming in the power, you take log on both the sides and then you take limit n tending to infinity and then you solve it. Because now you can see इस stage पे जाके this has converted into another indeterminate form, which is 0 by 0. But all of us knows we do have the solution of 0 by 0 form and infinity by infinity method. चाहे infinity by infinity form बने या 0 by 0 form बने, we know that we have the L'Hopital rule is there, right? So solving that way, when you will be doing the derivative above and below, this way you will be getting the limit. So this is an easy technique to deal with this kind of functions. So you will have plenty of examples to practice these techniques in your book. So practice that, right? So I hope that is clear. Now let's move ahead to the next part of the chapter, which is series. So I would like to say here, even those who are attending this as their first class or they are new admissions, so please be consistent from this lecture onwards, because the previous lectures you can still get it on the LMS, all the links, but this is going to be completely connected from this point onwards. Series. It is a bit different from the sequences. In fact, it is entirely different from the sequences. I'll explain what is the connection between them. Right. So first of all, we should understand the meaning of the word series. What do you mean by series? So series is actually series is basically, what is the difference between sequence and series? First of all, we need to look at that. You know, what was sequence? Sequence was just a number of terms arranged in an order. It's a list of numbers arranged in an order. So that number can be anything. So that can be 1, 2, 3, 4, 5. That can be 2, 4, 6, 8, and so on. 1, 1 by 2, 1 by 3. So we had plenty of examples of the sequences. So this was first term of the sequence, second term, third term, fourth term, and fifth term. That is how we were identifying the terms of the sequences at the place which they appear in the sequence. And each term was separated by commas, right? That's how we depict a sequence when we write it in this form. Otherwise, अगर हम उसको general form में लिखते हैं, general term में, so we know we express the sequence like this. We write what is going to be the expression for general term, but we know that elaborate करके उसका meaning ये है that the terms are there which are coming in an order and separated by commas. So sequence, now we are clear what is a sequence. So what is a series? So now if I just add all the terms, I have a sequence, but I introduce the signs of addition plus inside all the terms. So that becomes a series. And since sequences which we studied, they were also infinite sequence. So series which we'll be constructing will be also infinite series. So actually infinite series is nothing but infinite sum. This is the sum of infinitely many terms, infinitely many numbers, because this is continuously going, it keeps on going, it never stops, right? So this is infinite series is actually infinite sum. So that is the basic idea of how a series look like. The terms are there. This is the first term, this is the second term, third term, and so on. These are the terms, but they are separated. They are not separated by commas. Rather, we have the sign of plus in between them, right? So that's the meaning of infinite series, right? So the question arises in our mind, why we do not study finite series, right? Finite series means there is no need to study them. What will be a finite series look like? Finite series will look like 2 plus 3 plus 5. So this is just the sum of finitely many terms. You can count the number of terms. So I can see there are just 3 terms. So if you'll be adding them, this is a well-defined sum. Everybody can do that addition. Or if you cannot do that addition, at least the calculator or the computer can do that because this is something finite. Whatsoever you have a supercomputer, you have a very high processor computer, you are working with a very efficient machine which can do billions of calculation, but even billions is a finite number. So the computers are built up for doing the finite number of additions, and even the calculators, even us, we can just add the finitely many numbers. So the sum of finitely many numbers is always defined. The sum of finitely many numbers is always defined. So there is no point in analyzing this, that what is going to be this. This is just going to be an answer. We are definitely going to get an answer for that. The problem arises when you write it in an infinite way, right? If I write 1 plus 3 plus 5 plus 7 plus 9 and so on. So I really am confused whether it will make sense or not. Whether the infinite sum, the sum of infinitely many term, whether it makes sense or not. Makes sense means whether I will be able to write here something or not, right? So that is the question whose answer we are searching for. In what cases the infinite sum or the infinite series makes sense. तो ये जो मैं word use कर रही हूँ makes sense, this actually means in the language of this chapter convergent. तो अगर आप एक डेफिनेट आंसर उस इनफाइनाइट सम का लिख पाओगे, सो दैट सीरीज इज द कन्वर्जेंट सीरीज, अदरवाइज इट इज डाइवर्जेंट, राइट? अब सीक्वेंस की कन्वर्जेंस और डाइवर्जेंस को यहाँ पे कंफ्यूज नहीं करना है. सीक्वेंस में सम नहीं था, सीक्वेंस में सिर्फ एक टर्म का जो बिहेवियर था, द जनरल टर्म बिहेवियर वाज डिसाइडिंग द कन्वर्जेंस एंड डाइवर्जेंस. बट सीरीज में भी हम an से डिसाइड करेंगे, यू विल सी, बट द वे सीरीज कन्वर्जेंस डाइवर्जेंस इज डिसाइडेड इज इंटायरली डिफरेंट, क्योंकि यहाँ पे कन्वर्जेंट होने का मीनिंग ही अलग है, राइट? तो सीरीज में कन्वर्जेंट होने का मतलब ये रहेगा कि इनफाइनाइट सम जो आपने लिखा है, वेदर इट इज मेकिंग सेंस टू यू और नॉट, वेदर इट इज इक्वल टू. सो ऑब्वियसली इट्स अ वेरी बिग थिंग. आप इन्फिनिटली मेनी टर्म्स को ऐड करो और आंसर फिर भी एक फाइनाइट नंबर आए. So that is really a remarkable property of the infinite series, right? Can we imagine this anywhere? कि आप add ही करते जा रहे हो, you just keep on adding infinitely many times some positive quantity in a series, but still you are able to get a finite number. So that is the beauty of the convergence of the series. So we will be looking for that kind of series. We'll be looking for when does a series is convergent. So I told you in the very first lecture, इस पूरे chapter में एक ही question address होता है, whether the sequence is convergent. Now our question is going to be whether the series. So हम series ही लिखेंगे, but actual में infinite series ही है, because finite के लिए I just told you finite के लिए convergence does not make sense. Convergence is just कि जब infinite है तभी उसका concept आता है. Finite number तो वैसे ही well defined होता है. Finitely many terms ka sum. So don't look at that. We're just going to focus on infinite series, whether that is convergent or not. So you will see there will be plenty of techniques which will be learning depending upon series to series. कि किसी अलग तरह की series की convergence determine करने का different technique है, different series के लिए different technique है. So we have to learn all those techniques in this chapter in a very strategical manner. We just don't need to cram them, but we just need to understand the fundamental behind them. So this was just an intuitive understanding of convergent, right? I'll give you the formal definition later on, but ये सिर्फ starting के लिए, you should now clear with the meaning of what do you mean by when we will be saying whether the series, infinite series, is convergent or not, right? So just for an example, we know that we all are familiar with this kind of series, right? We know that this is the series we have. This is actually an infinite series. So this is the exponential function, right? So do you think how your calculator is doing the calculation? When you put in your calculator e raised to power 2, it's going to give you some answer. Or even if you put e, it will give you the answer, the value of the e. So how this is doing the calculation? So all our calculators and computers, they are giving us the approximate values. Nobody, no machine is ever going to give you the exact value because these are irrational numbers. You know the properties of irrational numbers? They keep on repeating. The decimal representation, if you will be expanded, it's decimal representation, you know, it's not going to be repeating, it's not going to be stopping anywhere, terminating. So it will keep on, you'll keep on getting the decimal. But no computer or calculator is made to display infinitely many digits. So they will display only up to finitely many values, right? Yeah, so to answer your question, Lavish, yeah, subtraction is allowed. We will look at that. Actually, subtraction को addition का ही part माना जाता है. जब हम series में subtraction वाली terms करते हैं, so वो उसको ऐसे include कर लेते हैं कि ये term का ही part है जो minus है, right? तो in general उसको sum ही बोला जाता है. So that's why we just say sum. But obviously the terms can be negative also, so subtraction भी बीच में include हो जाएगा. Yes, so what I was telling you about this, that whenever you will be looking at the value, actually your calculator is doing using this concept of series to calculate that value. वो कैसे यूज कर रहा है क्या है वो हम डिटेल में लास्ट में करेंगे जब हम इस तरह की सीरीज करेंगे. दिस इज अ वेरी specific type of series known as power series. This will come in a later section of the chapter. So then we will look at that. But this is just to give you an example of the series. Let's move to simpler example. So I just gave you one example, 1 plus 2 plus 3 plus 4 plus 5, right? This is one series, 1 plus half plus 1 by 3 plus 1 by 4 and so on. You can have other examples, 1 plus half plus 1 by 4 plus 1 by 8 and so on. So you can create your own series. It's just you have to arrange the numbers and just put the signs of addition in that, and that has to be an infinite series. डिफाइन आप कुछ भी कर सकते हो. उसके बाद क्वेश्चन स्टार्ट होता है कि अच्छा अब वो कन्वर्जेंट है कि नहीं है, राइट? सो दिस इज just few examples of the series. This is also an example of the series. 1 minus half plus 1 by 3 minus 1 by 4 plus 1 by 5 and so on. As I told you, the subtraction is also allowed. तो subtraction भी हो सकती है कुछ terms की, सारी terms subtraction भी हो सकते हैं. So everything is possible. Alternatively plus minus भी हो सकते हैं. So subtraction is also included whenever I'm using the word finite, infinite sum. तो कुछ terms हो सकते हैं उसमें जो subtract हो रही हो, right? Right. So this is just about examples. Now, if you talk about the notation, right? Power series हम last में करेंगे. I'm not going to comment on that. Yes, this 1 minus 1 plus 1 minus 1 plus 1 minus 1. This is definitely an example of a infinite series. Right. So let's introduce the notation. So जैसे sequence की notation थी हमारी an. So this was sequence, general term, and we were calling it the nth term of the sequence. और sequence को कैसे denote कर रहे थे हम? Curly braces में, right? अगर मैं general term को brackets में लिख दूं, so actually this means I mean this sequence. But अब series के लिए हमारी जो notation होगी, that is going to be summation. Right? Summation an. Summation, obviously you understand this is a sign sigma. This is summation. Summation means you are adding up the terms. So this is n equals to 1 to infinity. So this is going to be our usual notation for a series. That whenever you have this an in front of you, so then you are going to denote it like this. So you can, we will be introducing this notation for many series. Let me just tell you how it is. So this is usually n starts from 1. So that's what, if you elaborate this, it basically means a1 plus a2 plus a3 plus a4 and so on. or goes up to infinity. So ये and so on लिखने का ये मतलब है it's going up to infinity, right? So this is going to be the notation. So the question, the students mostly इसी में confuse हो जाते हैं क्योंकि sequence में भी हम general term के लिए an use करते हैं और series में भी general term के लिए हम an ही use करते हैं. But the difference is this. Here you have the brackets for the sequence, but for series you have the summation, right? So you can identify कि ये जो an given है ये sequence का general term है कि series का, because sequence की convergence के results अलग हैं, series की convergence देखने के results जो होंगे अलग होंगे, right? So moving ahead, so now let me define, now let me connect the sequence and the series. What is the connection between the sequence and the series? Because जब मैंने आपको sequence introduce किया था, that time I told you that sequence की convergence is connected with the series convergence. So this is going to be the first connection which we are going to study, that how a sequence is connected to the series. Means अगर हमें sequence की convergence देखनी आती है तो हम series से उसको कैसे connect कर सकते हैं. So for that we need to look at this definition of nth partial sum, right? Nth partial sum. So let's see what do we mean by that. So consider we have an infinite series which is like summation n equals to 1 to infinity an. So this is actually a1 plus a2 plus a3 and so on, right? So okay, again I'm telling you one thing, usually n equals to 1 to infinity hota hai, but you will see in many of the questions 0 se bhi start ho sakta hai, kyunki sequence mein hum kehte the domain has to be the natural numbers, but कुछ books में, and you might be knowing that even in many of the programming languages your index starts from 0, so they start terms like a0 a1 a2, so आपका n 0 से भी start हो सकता है. So you just have to be paying attention to it whenever you are solving the question of convergence. और बाद में हम discuss भी करेंगे कि actual में इससे कोई फर्क नहीं पड़ता है, ये बाद में हम कॉन्वर्जेंस डिटेल में डिस्कस करेंगे. देन आई विल टेल यू कि ये n2 से भी स्टार्ट हो या 3 से भी स्टार्ट हो तो उससे क्या फर्क पड़ेगा. विल डिस्कस दैट इन डिटेल, बट फॉर द टाइम being you just have to consider the fact that n starts from 1. So let me define the nth partial sum. So S1, so I'm defining a sequence. अब इस सीरीज से हम एक सीक्वेंस डिफाइन करेंगे, नया सीक्वेंस. सो उसकी पहली टर्म है S1, सो पहली टर्म इज जस्ट A1. S2, the second term of that sequence which I'm going to define. अब हम एक सीरीज के साथ, हर एक सीरीज के साथ एक सीक्वेंस कनेक्टेड होता है. अब वो कौन सा सीक्वेंस है वो हम डिफाइन कर रहे हैं, एंड हाउ इट इज डिफाइंड. सो फर्स्ट टर्म ऑफ द सीक्वेंस इज जस्ट फर्स्ट टर्म ऑफ द सीरीज A1. Second term of the sequence is A1 plus A2, right? Third term of the sequence is A1 plus A2 plus A3. And similarly, you can write down the nth term of the sequence is going to be A1 plus A2 plus A3 and so on up to AN. यहाँ पे ये नहीं लिखना है, right? ये Sn में जब आप लिख रहे हो then it is not and so on, because Sn is the nth term, it is the sum of first n terms of series. तो यही हमारी sequence की general term की definition है कि a sequence whose Sn, whose general term is, means ये जो Sn है, this is actually A1 plus A2 plus AN. ये जो sequence बनेगा, this sequence is called sequence of partial sums of the series summation AN. तो actual में आपकी series जो है infinite series है, but आप उसमें से एक sequence define कर सकते हो which is sequence of partial sums, and it is defined like that. So the first term is A1, the second term is A1 plus A2, the nth term is sum up to n terms, right? So an nth partial sum. So this Sn is called nth partial sum, राइट. सो आई विल गिव यू एग्जांपल. जब हम इसका एग्जांपल करेंगे, क्वेश्चन करेंगे, देन यू विल बी मोर क्लियर अबाउट इट कि कैसे डिफाइन करते हैं सीक्वेंस ऑफ पार्शियल सम्स फ्रॉम अ गिवन सीरीज. राइट, विल डू द एग्जांपल, देन इट विल बी, बहुत सारे एग्जांपल्स करेंगे जिसमें हम ये कॉन्सेप्ट यूज करेंगे. बट राइट नाउ इट्स अबाउट अंडरस्टैंडिंग द डेफिनेशन. With every series there is a sequence connected and that sequence is the sequence of partial sums of the series. और उसको ऐसे डिफाइन किया जाता है, S1 is A1, S2 is A1 plus A2 and so on. So now let's look at the result. So there is a theorem. We are not going to do proof of it, but this is the result which is connecting the convergence of the sequence with convergence of the series. So this theorem says that the series summation n equals to 1 to infinity an converges if and only if this sequence Sn converges. तो ये Sn is not arbitrary notation. तो जब भी आपको सीरीज के कंटेक्स्ट में ये Sn नोटेशन दिखेगा, so it always means they are they are defining it as a sequence of partial sums. So this is a very strong result. It connects you with the sequence कि अगर sequence of partial sums उस series का converge करेगा तो series भी converge करेगा, right? Because you know our question is still the same. हमने series define किया है. Our question is whether this series is convergent or not. So here we are providing an answer with the help of sequence of partial sums. कि अगर आप उस सीरीज की कन्वर्जेंस आइडेंटिफाई करना चाहते हो तो आप उसके सीक्वेंस ऑफ पार्शियल सम्स की कन्वर्जेंस निकाल लो. अब सीक्वेंस की कन्वर्जेंस हमें देखना आता है ऑलरेडी, यू नो, जो हमने अभी एग्जांपल किया था लिमिट वाला टेक्निक, क्योंकि सीक्वेंस की कन्वर्जेंस हमें देखनी आती है. तो अगर हम सीरीज की कन्वर्जेंस देखना चाहते हैं, सो व्हाट यू हैव टू डू इज उसका आप nth पार्शियल सम्स से सीक्वेंस कंस्ट्रक्ट करो और अगर वो कन्वर्ज करेगा तो सीरीज भी कन्वर्ज करेगी, अदरवाइज नहीं. क्योंकि ये जो रिजल्ट है दिस इज इफ एंड ओनली इफ. एक्सप्लेन्ड यू द मीनिंग ऑफ इफ एंड ओनली इफ. दिस मीन्स it is true both sides. Both side means if this sequence converges then the series also converges, and if this sequence Sn diverges then the series also diverges, right? Most of the time मैं simply ऐसे summation लिख दिया करूंगी क्योंकि हम बार बार ऐसे नहीं लिखते हैं, वो understood ही होता है, right? Just to save the time, but otherwise do not get confused कि summation अकेला लिखा है. Most of the times हम उसको ऐसे लिखा करेंगे. So this is what this result mean कि अगर उसका nth partial sum का sequence converge करेगा, series converge करेगी, otherwise नहीं करेगी. Means diverge करेगा तो series भी diverge करेगी. And this result continues. And if Sn converges to L, अब हम कह रहे हैं कि अगर वो सीक्वेंस कन्वर्ज करता है तो ऑब्वियसली उसकी कोई फाइनाइट एंड यूनिक लिमिट होगी. सो सपोज वो L को कन्वर्ज कर रहा है, then the series summation n this one is also L, right? अब ये लिखने का मतलब है, अब इसको आप दो चीजें बोल सकते हो. ये जो मैंने नोटेशन लिखा है ऐसे, इसके दो मीनिंग है. इसको आप ये भी समझ सकते हो, the series summation an converges to L, or it also means the sum of the series summation an is equal to L. So ये दो मीनिंग है. दो मीनिंग मीन दोनों का मीनिंग एक ही है, बट उसको दो लैंग्वेजेस में यूज किया जाता है. बिकॉज जो मैंने आपको बिगिनिंग में सीरीज की कन्वर्जेंस का मतलब समझाया है, उसका ये मतलब है कि उसका जो सम होगा इनफाइनाइट सीरीज का वो वेल डिफाइंड होगा. तो अगर आपको वो वेल डिफाइंड नंबर मिल रहा है किसी भी सम के लिए, सो दैट मीन्स वो सीरीज कन्वर्जेंट है. सो इस केस में दिस रिजल्ट इज टेलिंग यू कि अगर ये सीक्वेंस पार्शियल सम्स का कन्वर्ज करेगा तो उसकी कोई लिमिट होगी, तो हम इंप्लाई कर लेंगे अच्छा फिर वो ही लिमिट जो है वो सीरीज की भी है. सीरीज का जो सम है दैट विल बी एग्जैक्टली इक्वल टू दैट लिमिट. सो दिस इज अ वेरी स्ट्रॉन्ग रिजल्ट. हम प्रूफ नहीं करेंगे, सो डोंट ट्राई टू डिग इनटू कि ये कैसे आया, क्योंकि ये कैसे आया, ये कैसे कनेक्शन है, वो प्रूफ से ही समझ में आएगा हमको. बट राइट नाउ वी जस्ट हैव टू use this result in the questions and apply this one, right? So I'm going to give you one example of the same. So let's apply this on an example. Say trivial example लेते हैं सबसे पहले. हम constant series का example लेते हैं. अब मैं आपको रिमाइंड कराते रहूंगी कि कांस्टेंट सीक्वेंस हमने किया हुआ है. इफ यू रिमेंबर, कांस्टेंट सीक्वेंस था हमारे पास. कांस्टेंट सीक्वेंस इज कन्वर्जेंट. सीक्वेंस जो कांस्टेंट होती है लाइक 3 3 3 -4 -4 -4 whatever be the real number, the constant sequence is always convergent. So let's see constant series कैसे होगी. So constant series is, ये कोई फॉर्मल टर्म नहीं है, ये सिर्फ हमने अपने समझने के लिए बनाई हुई है, but you can easily look at that and understand. For example, very simple example. Let's try to understand this. 1 + 1 + 1 + 1. You keep on adding 1 to itself infinitely many times, right? So all of us otherwise can understand कि ये infinite होगा sum, right? We can understand 1 + 1 + 1. You keep on adding any number to itself infinitely many times. That's obviously the answer is going to be infinity. So we know that already, but let's try to understand this through the example of partial sums. तो इस series का हम partial sums construct करते हैं. So A1 is 1. So S1 is A1, which is 1. A2 is 2, but S2 is A1 plus A2. That is the sum of first two terms. So this is 1 + 1, which is 2. Similarly, S3 will be A1 plus A2 plus A3, which will be 1 + 1 + 1, which will be 3. S4 will be 4. ये अब 3-4 terms लिखने के बाद आपको pattern दिखना शुरू हो जाता है. You can see this 1 2 3. S1 is 1, S2 is 2, S3 is 3, so S4 is 4. This gives you the general term of the sequence. So जब भी आप sequence वाले method से, ये वाले method से जो भी हम question करेंगे, उसमें important होगा ये identify करना कि general term हमें मिल जाए. क्योंकि एक बार हमें sequence का general term मिल गया, we will be able to look at its convergence and divergence. Yeah, thank you Bhavika. A2 is 1. Yeah, सारी terms 1 ही है उस series की. Yeah, so this Sn is n. अब हमने हमारा result क्या कह रहा है कि अगर ये sequence converge करेगा तो series भी converge करेगी, और अगर sequence diverge करेगा तो series भी diverge करेगी. तो we know already ये sequence convergent है क्या divergent? You write your answers in chat box. This sequence Sn is equal to n is convergent or not? This is a question I'm asking. This Sn, अब इसको बस ये notation Sn है, but actually you know this is a sequence, so we know whether this is convergent or divergent. कैसे देखते हैं? Just we take limit n tending to infinity n, उसकी general term, so we know that that is going to infinity. So this sequence is definitely convergent, divergent. This sequence is divergent because its general term is going to infinity. So since this sequence is divergent, therefore by using that theorem जो result अभी हमने state किया था, this given series also divergent. और जब डाइवर्जेंट आती है तब लिमिट का कोई सेंस नहीं होता, फिर हम लिमिट की बात नहीं करते कि अच्छा उसकी लिमिट क्या होगी, ये सम ऑफ द सीरीज क्या होगा. जब हमने बोल ही दिया वो डाइवर्जेंट है तो सम ऑफ द सीरीज डज नॉट मेक सेंस, राइट? सो हमें डाइवर्जेंट सीरीज के लिए कभी भी ये क्वेश्चन नहीं पूछना है कि उसका सम क्या है. तो इफ somebody asks you what is the sum of the series, so firstly you should confirm whether that series is convergent or not. तो ये डाइवर्जेंट सीरीज है तो इसका सम डिफाइंड नहीं है. So you got a result, constant series is always divergent. ये तो हमने एक एग्जांपल किया है 1 + 1 + 1 + 1. आप कोई और एग्जांपल ले लो, 2 + 2 + 2 ले लो, 3 + 3 ले लो, कुछ भी ले लो. You try it on any example through the similar kind of analysis, you will always see that this series is always divergent. So जैसे कांस्टेंट सीक्वेंस का हमने रिजल्ट ऑलमोस्ट याद ही कर लिया है कि कांस्टेंट सीक्वेंस कन्वर्जेंट ही होती है, तो कांस्टेंट सीरीज हमेशा डाइवर्जेंट ही होती है. So this was the first example. and we actually applied this result to conclude that that series is divergent. So let me give you one more example. Let's take this series 1 minus 1 plus 1 minus 1 plus 1 minus 1 and so on. So ऑब्वियसली 4 to 5 टर्म्स लिखने के बाद ही हमें पैटर्न नजर आना शुरू होता है. तो पैटर्न क्या है कि टर्म्स जो है ऑल्टरनेटिवली क्या है हमारे पास नेगेटिव पॉजिटिव है. सो लेट्स ट्राई टू डू दिस विद द सेम वे वी डिड द फर्स्ट क्वेश्चन. सो इसका हम पार्शियल सम्स का सीक्वेंस कंस्ट्रक्ट करते हैं. सो a1 is 1, so s1 is 1, a2 is minus 1, you can see that, and s2 is a1 plus a2, so this is 1 minus 1 which is 0. a3 is plus 1 again, you can see uski terms alternatively negative positive hai. So s3 is a1 plus a2 plus a3, so 1 minus 1 plus 1 which is 0 plus 1 which is 1, right? ये मैं देखो फर्स्ट कुछ एग्जांपल्स हैं तो मैं ज्यादा डिटेल में लिख रही हूँ, बट व्हेन यू विल हैव इनफ प्रैक्टिस ऑन दिस तो आप सीधा s1 s2 s3 डायरेक्टली लिख सकते हो. उसके बाद नेक्स्ट टर्म फिर से नेगेटिव है, सो s4 विल बी अगेन 0 एंड सो ऑन. सो एंड सो ऑन. अब मुझे पैटर्न आइडेंटिफाई करना था यहां से, तो लेट्स सी. Yeah, so let's see. Yeah, what will be the general term of this? I'm writing it here. So general term इसकी इस तरह से नहीं आएगी, जैसे इसमें सीधी दिख गई थी n 1 2 3 4, so we directly write nth term is n. But इसमें पैटर्न क्या है 1 0 1 0. तो Sn actually क्या है, it's 1 if n is odd and it is 0 if n is even. मीन्स जो आपकी सीक्वेंस ऑफ पार्शियल सम्स बनी है इस सीरीज का वो बेसिकली ये है 1 0 1 0 1 0, राइट? उसकी ऑड वाली टर्म्स 1 है, इवन वाली टर्म्स 0 है. सो नाउ यू गिव मी एन आंसर फॉर दिस, वेदर दिस इज कन्वर्जेंट और डाइवर्जेंट. अब आपका क्वेश्चन देखो ना, अब आप सीरीज को भूल जाओ. अब आपका क्वेश्चन सिर्फ सीक्वेंस पे आके फोकस हो गया, और सीक्वेंस की कन्वर्जेंस डाइवर्जेंस हमें देखनी आती है. तो ये सीक्वेंस जो आपके सामने लिखा है 1 0 1 0 1 0, ये कन्वर्जेंट है कि डाइवर्जेंट? यस प्लीज, आई एम एक्सपेक्टिंग.
है कन्वर्जेंट.
Okay, yes, yeah, we are back with it. Let me write the same question. So we were doing this series 1 plus 1 minus 1 alternatively. हमने इसका sequence of partial sums construct किया था, so that was turning out to be this. If n is odd, it was 1. If n is even, so this was 0. So this sequence is divergent because we know उसकी लिमिट यूनिक नहीं है. अगर आप इसकी लिमिट n टेंडिंग टू इंफिनिटी लोगे Sn की, so वो भी यही आएगी 1 means actually I should not write. Actually we will be writing this limit is not defined because वो fluctuate कर रही है 1 और 0 के बीच में. So this sequence is divergent. So because of that result जो series की convergence को connect कर रहा था इस sequence की convergence से, so we will imply this series is also divergent, right? तो ये दोनों जो examples अभी हमने किए हैं, एक हमने की है इस तरह की series की जिसमें कोई भी कांस्टेंट नंबर है, ये मैंने 1 का एग्जांपल लिया था, बट कोई भी कांस्टेंट नंबर यू ऐड कीप ऑन एडिंग टू इटसेल्फ इनफिनिटली मेनी टाइम्स, तो ऑब्वियसली वो इंफिनिटी ही होता है उसका सम. इट इज नेवर कन्वर्जेंट, बट वी सॉ हाउ टू प्रूव दैट यूजिंग दैट मेथड. सिमिलरली दिस वन इज हियर, so we are proving, we have proved using the method that this is divergent. Okay, so I'm going to repeat this example. Those who are saying this, so ये series था हमारा 1 minus 1 plus 1 minus 1 plus 1 and so on. So हमें क्या करना है, आप टेक्निक सीखो, हमें sequence of partial sums construct करना है इसका. So उसके लिए S1 is the just the first term, S2 is A1 plus A2 which is 1 minus 1. पहली दो terms को लेना है आपको. So 1 minus 1 which is 0. S3 is पहली तीन terms को लेना है. तो पहली तीन terms means this. So this is 1 minus 1 plus 1. This is 1. Similarly, S4 will be again 0. क्योंकि आप चार टर्म्स लोगे मीन्स दिस 1 minus 1 plus 1 minus 1. So again 0. So आप जब और एग्जांपल्स करोगे तो ये बीच में चाहे आप ना भी लिखोगे तो दैट्स फाइन. आपको मीनिंग क्लियर होना चाहिए सीक्वेंस ऑफ पार्शियल सम्स का. दिस इज 1 0 1 0 1 0. तो जब हम इसको एज अ सीक्वेंस लिखेंगे तो इस सीरीज का जो सीक्वेंस ऑफ पार्शियल सम्स है वो ये है 1 0 1 0 1 0 एंड दिस इज एक्चुअली अ डाइवर्जेंट सीक्वेंस. देयरफॉर ये जो आपकी ओरिजिनल सीरीज है जो आपको गिवन है, गिवन सीरीज इज ऑल्सो डाइवर्जेंट, राइट? So yeah, will not be doing more examples. I can take your doubts. Yes, those of you who are getting confused between that whether this will be 0, so no, the sum is not well defined, right? अब infinitely many terms को आप imagine नहीं कर सकते हो. Infinitely many terms कैसे behave कर रही हैं? अब कोई बोलेगा इसका sum 0 है, उसने even number of terms consider कर ली. मान लो उसने 10 raised to power से 20 टर्म्स कंसीडर कर ली, इनफाइनाइटली मेनी टर्म्स से इस सीरीज की बात कर रहे हैं, तो ये इवन नंबर है. सो आप बोलोगे कि इस सीरीज का सम जो है 0 है, बट वो उस सीरीज का सम नहीं है, वो 10 रेज़्ड टू पावर 20 टर्म्स का जो सम है वो 0 है. आई विल इमीडिएटली से कि नहीं, इस सीरीज का सम 0 नहीं हो सकता है, बिकॉज मैं इमीडिएटली उसमें जो एक नेक्स्ट टर्म है वो ऐड करूंगी, उसका सम हो जाएगा 0 + 1 1. तो जो सम ऑफ द सीरीज है वो डिफाइंड नहीं हुआ ना, वो कभी 0 है कभी 1 है, फिर 0 आएगा फिर 1 आएगा. तो जैसे आप टर्म्स को ऐड सब्ट्रैक्ट करते जाओगे, उसका सम फ्लक्चुएट कर रहा है. एक बार सम 0 होता है, वो -1 और +1 एक दूसरे को बैलेंस करते हैं, इमीडिएटली नेक्स्ट टर्म आते ही वो फिर से +1 हो जाता है. सो ये कन्वर्जेंट सीरीज नहीं है. इट इज द सम ऑफ द सीरीज इज फ्लक्चुएटिंग बिटवीन 0 1 0 1 0 1, राइट? यू कैन सी, यही तो उसकी सीक्वेंस बताती है. तो सीक्वेंस ऑफ पार्शियल सम्स यही बताते हैं कि अगर आप फाइनाइटली मेनी टर्म्स को ऐड करो और फिर उसको एनालाइज करो, सो देन हमें बिहेवियर पता चलता है. तो दोज ऑफ यू आर गेटिंग कंफ्यूज्ड कि ये सीरीज कन्वर्जेंट होगा क्योंकि इसका सम वेल डिफाइंड है, सो द आंसर इज नो. बिकॉज आप ये मत देखो ना कि मैंने इतनी ही टर्म्स लिखी हैं तो यहां से 0 आ रहा है, इमीडिएटली एक टर्म और लिखते ही उसका सम चेंज हो जाएगा, एंड एक्चुअली द नंबर ऑफ टर्म्स इज इनफाइनाइट. सो दिस सीरीज इज अ डाइवर्जेंट सीरीज, इसका सम डिफाइंड नहीं है, राइट? सो डाइवर्जेंट मींस वो ऑसिलेटरी बोल सकते हो, मैंने पहले भी आपको क्लियर किया था. डोंट गेट द कंफ्यूज्ड इन द टर्म्स कि ऑसिलेटरी भी है, वो है ऑसिलेटरी, बट वी हैव जस्ट इंक्लूडेड एवरीथिंग अदर देन कन्वर्जेंट इन द डाइवर्जेंट. जो कन्वर्जेंट नहीं है उसको बस हम डाइवर्जेंट बोल देते हैं. सो यस, इट इज ऑसिलेटरी, बट एक्चुअली विल पुटिंग इन द कैटेगरी ऑफ डाइवर्जेंट. अभी आप और किसी सीरीज पे मत जाओ, पूरा चैप्टर है, बहुत सारे एग्जांपल्स करेंगे, राइट? अभी आप सिर्फ इन दोनों एग्जांपल्स के बारे में आप कुछ पूछना चाहते हो, सो यू कैन आस्क. बिकॉज ये वाली जो एग्जांपल्स हैं ये सिर्फ उस रिजल्ट को समझाने के लिए करी है मैंने, जो अपने रिजल्ट हमने स्टेट किया था सीक्वेंस का, उस रिजल्ट को अभी हमने और भी बहुत सारे क्वेश्चंस में अप्लाई करना है. सो यू विल गेट अ बेटर क्लैरिटी ऑफ दैट, बट दिस वाज answer to these two examples found through that method. Yes, Ashna. Right? So yeah, I'm just going to wind off. We'll continue from the same point tomorrow.